So what do we have? We have a beam with a UDL. Our UDL is 85 kilonewtons per metre. And it's a 5 metre length, simply supported beam. We've been given that the beam is this 406,178 times by 54 in terms of weight. And we've got the E value for steel. As soon as you see the beam given here, then you know that you've got to refer to the tables at the back of your handout or the back of the exam. And we're told also that our maximum deflection that we're allowed is span over 360. So with this information here, we go to the tables and we'll pick off our I value. So we've got IXX. Now we've always been looking at our forces being applied vertically. So if we looked at this beam here, so it's an I beam, and the UDL is being applied at the top across the XX axis. Now if there was like a horizontal force, then that's when we'd have to start getting the IYY values. If the force was slightly off to the side, we'd have to consider if there'd be a bit of a twist, so we'd have to start looking at the IYY. But for this topic from last week, our IXX from the tables is 18720 centimetres to the 4. Now it's always best to put everything into newtons and millimetres or kilonewtons and metres. So we'll put 187.2 times 10 to the 6 millimetres to the 4. Unfortunately, you've got to get around units quite quickly. You find that all of the tables that provide details regarding beams, they're all in centimetres to the 4. So you always have to convert them into millimetres. And then picking off the formula from the back of the handout. So if we're looking for a simply supported beam, we'd be able to pick off our deflection. And again, you don't have to remember these formulas because they're on the formula sheet. So for a simply supported beam with a UDL, this is the formula that we'd be using to work out the actual deflection that we're expecting from this loading scenario. We've got our W is 85 kilonewtons per metre, so that's our UDL multiplied by our L, which is 5 metres. That gives us 425 kilonewtons. So that's our capital W. Remember last week that we were looking at, depending on which chart you look at, these formula can either contain a capital W, which is your total load, or it can be a small w, which represents the UDL. And make sure that you get apply the correct one. And we got our length, which is 5 metres, which is also 5,000 millimetres. So most of this information is from the question or from the tables. So if we wanted to work out what our deflection is, let's put all of our values into here. So 5/384. We'll put everything into newtons and millimetres. So our W is 425 times 10 to the 3 newtons times by 5,000 millimetres cubed. Our A value is given in kilonewtons per millimetre squared. So we're going to change that kilonewtons into newtons. So we're just going to times this 205 by 10 to the 3. That's to put it into newtons per millimetre squared. And then our I value is 187.2 times 10 to the 6. That gives us an actual deflection of 18.09 millimetres. If we compare that to our allowable, so our allowable deflection is span over 360. So it's our 5 metres over 360. It's 13.89. We are allowed around about 40 millimetres. It actually deflects 18 millimetres, therefore it fails. Now the things that we can play around with, we could, if you can adjust the span, if you can adjust the load, then you could make them smaller to reduce the deflection. Or you can look at the I value, so you could pick a thicker beam with a larger value. So you're more likely to adjust that to make sure that your actual deflection is less than the 13.89. If we took this formula here and we wanted to know what load could this beam take, given that the allowable deflection is 13.89, so you just take your deflection formula, put 13.89 within there, and then put all of the other values in. But then you could either rearrange that or just multiply everything out, and you'd find that your W is 327 times 10 to the 3 newtons. So that's the maximum load that it could be taken. But quite often you'll start with your load, try and work out what you need to what sort of beam you need to support that load. You can't really adjust your load. And we also introduced like the strength of the materials. So we had, like, from our theory of simple bending, we had these formula where you could have sort of M is WL over 8, where that's looking at the moment that's been applied due to this UDL. That's your moment of resistance of the beam. So you can put your W sort of into there, then that will give you the moment that the beam can take. You can put that M into there. You can work out what the stress in the material is. You can get your elastic modulus from the table. So these are different ways of sort of playing around with the formula to try and decide either what beam do I need or what deflection am I allowed. And so that's a bit of a reminder of what we did last week.